So I'm going to expect that I've got a function, and it's going to be inside, and on the outside, I have the derivative of that function. You want to think of it as anti-chain rule. So if I were to look at this guy and think of it, this would be g of the blob, and out here is blob prime. And you notice it's the product of two functions. If it were the sum, that would be a different issue. Now, before we've had products whereby we had to perform algebra. These guys don't lend themselves to algebra. So in other words, I'd look at the problem and say, I can't do this thing using algebra. So it's either basic or algebra. Well, if it's not basic and it's not algebra, is it what we call a U substitution? That means it's anti-chain rule. It's anti-chain rule if I have a function and I've got inside that function another function, which we call the blob, and I look outside, I see it's multiplied times the derivative of the blob. You take it down to a basic, you integrate the basic, and then you take it back to the original. You take it back to the original function. So in other words, I make a substitution that takes it to the basic function. Once I've done that, I can integrate it. Once I've integrated it, then I do the replacement. And we've done that in the past, solving problems where we've had to make substitutions. So it works kind of like that. So here we go. Here's going to be our first. We start looking for the pattern. I first noticed this is the integral of 6x times 3x squared plus 1 to the 4th dx. Now I could solve this if I wanted to using algebra. I wouldn't necessarily want to. The reason why is that I would take a look at this and say, I would have to take 3x plus 1 and multiply it times itself 4 times. I wouldn't want to do that by hand. Maybe allow Wolfram Alpha to do it, but I wouldn't want to do it, right? So what would I do? Well, I noticed something. I have 3x squared plus 1 to the 4th power. I have a blob. Now, if the blob is 3x squared plus 1, what's blob prime? Do I see a 6x in my integrand? Yeah. That's blob prime. So that says, oh, this is a U substitution problem. How do I know that's a U substitution problem? I find the blob. I take the derivative of the blob. If I find that derivative, here's the guy here that's in question. That's what's left over. If what's left over is the derivative of the blob, I have a U substitution problem, where I let U be equal to the blob. Now, normally, this is what happens. We go to the notation. du dx, that's the derivative of u with respect to x, is 3x squared, or I'm sorry, 6x squared. Now, that's not how this thing operates, because I'm making a replacement. This is a 6. I don't have my white tape. That's not how this operates. In this integrand, I have to replace all x's in terms of u. There can be no x's surviving. So multiply both sides by dx. You get that du is going to be 6x squared dx. Now I go about to make the substitution. I'm going to rewrite this guy so I can write on top of him.
Why is it 6x squared?
Yeah.
Oh, it's only 6x.
Okay.
I notice the constants, by the way, are not going to matter. It's the variables. Any x that's there has to go. If I can take the whole thing, that would be great. Now, this is what I termed to be u. That's going to become u to the fourth. That's your blob. 6x dx, 6x dx, this whole thing becomes du. So what does this integral become? The integral of u to the fourth du. Is that a basic? And we know how to integrate that. That's u to 5 over 5 plus c. So everything gets turned in to a basic. We establish what the blob is. The blob gets replaced by u. I have a 6x and a dx, and I notice 6x dx is du. So this whole thing gets replaced by du. So now all x's are gone, and I'm down to something which is a basic integral.
So that's the answer?
Well, no, that's essentially the first step in the answer. If I want to go further, right, I integrate it out. This is u to the 5 over 5 plus c. That's Wednesday, okay, which is going to be 3x squared plus 1 to the 5th over 5 plus c. That's Wednesday. So this whole thing right here is Wednesday. And then this is your answer. But we have to be able to make the substitution first. You have to realize and visualize and work with it. How do we do this? It's kind of like putting pieces of a puzzle together now. And then I take a look at this guy. I've got 2x e to the, by the way, even under normal circumstances, I can't, e to the x squared is not a basic. E to the kx, constant times x is, but not x squared. 99% of the time, u is going to be the exponent of e, because e never goes away. Derivative of e to the x is e to the x. E to the anything is e to the anything. So e never goes away. So either e itself is u or its exponent. 90% of the time it's going to be the exponent. Okay, so going to be the exponent. And so if I take a look at this and I'd say, all right, here's e to the x squared. If x squared is the blob, then blob prime is what? 2x. Now, when I look at this integrand, do I see a 2x? Yeah. So here is essentially what I'm saying is going to be part of the u thing, And what's not part of the u thing is 2x. That's your multiplier. That's chain rule. E to the blob, e to the x squared, the derivative of x squared is 2x. Chain rule. So that tells me that u is x squared. Du, and you write it this way, is 2x dx, and we know how that happened. That happened from above. Du dx is equal to the derivative. Then you multiply both sides by dx, because you have to get rid of the dx as well, because why? That is your variable of integration. When you move to u is your variable of integration, and dx must turn into du. You can't have dx there anymore. So what do? I replace, any place I have an x squared, I put a u. So x squared becomes u. And 2x dx, this whole thing is du. Now anything with an x is gone. This is the integral of e to the u du. Now, is that a basic? Is this a basic? Is e to the u? What's the antiderivative of e to the u? E to the u. So this is a basic. And Wednesday, we take the antiderivative, and then this would be e to the x squared plus c.
Does it matter if the du goes before the e to the u?
No, yes it does, because it goes always at the end.
Okay.
It's going to be, and if you try to put that into Wolfram alpha, it would basically assume you're multiplying the integral by that quantity.
Du is always at the end.
Yep.